PreCalc, hello, hello, hello. We are watching this video on Thursday after class 9:29. So, yesterday in class, no, that was today in class, we learned how to find the graph of y equals sine x, cosine x, and tangent x. So with that, your groups came out and shared their information, and I'm going to take it from there. What we're going to add tonight, if you're watching it in the evening, is we're going to take this expression and we're going to alter it, and we're going to do that by putting a value in front of the word sine. Say we put in the value of, let's say we'll put in the value of 2. So today in class we learned that this function goes up to 1, down to -1. 0, 0 is on the graph. We have the 4 tick marks. So these correspond to the unit circle. At the top of the unit circle was pi over 2. To the left was pi. At the bottom was 3 pi over 2. And at the right we're back at 0 or 2 pi. So I'll put in a couple negative ones. Alright, so these repeat as we go to the left and with negative values. Can you tell these are negative? It's not real clear. Alright, so sine starts here. By pi over 2 it peaks, then it comes down to the 0 mark again at pi, then by 3 pi over 2 it's at its lowest, and then back up to 2 pi. Now that will continue in both directions, that same pattern, so I'll just show you that much. It goes forever. Alright, what happens when we put a number in front of the sine function? Well, let's put it in your calculator. So take y equals sine x, and make sure you're in radians. It shows up very accurately in radians. And then with that still on your screen, y1, put in y2 equals 2 sine of x, and see what the difference is. So we have a pause point while you go do that. Alright, you probably noticed from your expression then, let's move this out of the way, because this graph, when you put in a 2 in front of, I'll put it up higher, sine of x, now we're putting in y equals 2 sine of x. That 2 caused the graph, instead of going up to 1 and down to -1, it now goes up to 2 and down to -2. So it goes up, it still hits its peak at pi over 2, comes back down and is at 0 at pi, bottoms out at 3 pi over 2, and back to 0 at 2 pi. So we haven't caused the graph to stretch or narrow, but it has gone up higher at its highest point and lower at its lowest point, still going up and down around the center line provided by the x-axis. So I'll take that further so you can see it doesn't just stop there, and so on. So that value, when you put a value in front of the word sine or the expression sine x, it will cause this to happen. That has a name. It's called the amplitude. If you studied sound, you might have met this word before. And notice the amplitude is not the size of the graph from its lowest point to its highest point, like this would be, but it's from the center line, from the x-axis in this case, to the highest point. So that is 2. You could also call it the size of the graph from the x-axis to the lowest point. It's also 2, but you would ignore the direction. So we're just looking at the size, amplitude. So this has an amplitude of 2. Alright, this is a general rule for no matter what number you put in here. So if I call this y equals a sine x, you know to look at that position in front of the word sine to find the new graph's amplitude. So what do you think the graph would look like if I substituted a 1/2 sine x? I'm going to switch colors here. I hope it shows up in video land. So this time the curve is going to peak at 1/2 instead of up at 1 or at 2. And it's going to bottom out at -1/2. So you can see that its mountaintop is not as high, its valley is not as low. So amplitude, what we are studying today is a change in amplitude. All right, let's take a cosine function then and do the same thing. So the cosine function is very similar to the sine function, but it starts at a different spot on the y-axis. I'm still going to put in 0, pi over 2. Every graph has to have these tick marks at least. And -pi over 2, -pi. It's going to go, the normal curve is going to go up to 1 and down to -1. And when we start with the cosine curve, you'll recall from our knowledge today that the cosine curve starts at 1 on the y-axis, where the sine curve started here at 0. So it's going to come down through pi over 2, bottom out at pi, back up through 3 pi over 2. We'll hit the x-axis at 3 pi over 2 and peak again at pi. And that will continue on both sides. So, all right. So what do you suppose happens when I come in and take y equals cosine x and change it to y equals 1/2, so I'll say 3/2, which is 1/2 cosine x. What do you think will happen to the graph, having seen all this who-struck in reference to the sine curve? It works the same. This is the amplitude of the new cosine curve. Instead of going up to 1 and down to -1, it's going to go up to 1/2, so somewhere right there. And it's go down to -1/2, somewhere right here. Same curve, so I'm going to start here. It's still going to hit the x-axis at pi over 2. It's still going to bottom out at pi, but it's higher than the cosine of amplitude 1. There was an unwritten 1 there, so now we're going up and down 3/2 instead of 1. So you'll see it goes up higher and down lower. So the expression could have any constant there, y equals a cosine x. Here you'll know where to look in a function right there for the amplitude of the cosine curve. All right, I'm going to shut this down for now, but just for thinking, so we'll talk about this tomorrow. What do you think happens to the tangent curve when I put in a value? Try that on your calculator. Put in your tangent curve, observe what a normal tangent curve with an amplitude of 1, and then put in another number, say 2, 3, or even 1/2. And let's see what happens to the new tangent curve. We'll share that information tomorrow. Write down in your comp book what you think happens to a tangent curve when the number in front, the a, changes. All right. That's all we're going to talk about tonight. I will add a tiny piece to that in the morning before you start the work that will be comparable to this information. All right, have a good evening. Bye.